All right, now let's take a look at a second example. We are still using an exponential function as the base. I use e instead of 2 this time, but it's generally the same sort of thing. The only thing that's going to be different is we're going to have some extra algebra that involves ln and logs, and that's probably not fun, but maybe it'll be fun. Well, we're going to see, all right? So it's if you look at the graph in the upper right corner here, okay, it's the same type of function. It's just 2.718, which is e, instead of just a regular 2. Okay, it doesn't really affect the shape of the graph. The key point and the asymptotes are all the same. So let's get started with a mapping notation. So in this case, okay, we have x plus 1, and we have minus 2y plus 4. This time there is a number in front of the other number that's to the power of x. If you want to put a bracket in here, we can, all right? But we see that the y values are minus 2 and positive 4. And at this point, okay, we can put in our key point of 0, 1, and we can get a new key point right here, which is 1, 2. That is our key point. Once again, you can get a horizontal asymptote from the vertical translation. So we have a horizontal asymptote for this one, which is y is equal to 4. That comes directly from the mapping notation, the vertical translation. So we could sketch what we have so far. So we have something like this, and we could say, okay, well, at y is equal to 4, we have a horizontal asymptote. And we have a key point at 1, 2. Now, once again, okay, we can get x and y intercepts before we sketch the graph. This one's going to look a little different because on the mapping notation, you can see a negative in front of the y, which means it reflects around the x. So it's going to flip over the x-axis and look a little bit different. But why don't we instead, okay, why don't we just start off by getting some more information. So let's get a y-intercept. So we can do that first. Okay, we can get a y-intercept by plugging in 0 for x. This is maybe not as painful as the x-intercept. We'll see. So let's plug in 0 for x, and you're going to wind up with something like this, e to the negative 1. And you could put all of this in your calculator. Your calculator can do e to the negative 1 for you, and then times it by negative 2, and then add on a 4. So if you take a look at this right here, you are going to have a final solution of approximately 3.264. Okay, so we're going to have this point right here. That's going to be another key point on our graph. So we can say 3.264, somewhere around there. Okay, and then of course in some questions you're not even asked for the x and y intercept at all. But in this one we'll do it. And we're going to get the x-intercept next, which is plug in 0 for y. And you guys may not like this one as much. Or maybe you will. Most people don't like e and ln, all right? For some reason, okay, it's not very much fun for most people. But hey, we're going to do this. We're going to bring one thing over to the other side, and then we can divide both sides by 2. So we can try to isolate the x as much as possible. This is about as far as you're going to get. But if you remember from 12a, you can get rid of that e by getting the natural log of each side. If you do it to both sides of the equation, it's okay. And a natural log cancels out the e. This is really the step that we're doing, okay? This is something that I believe you have learned in 12a, is that natural log is really log subscript e, and then if the e's are the same, you can just say that they cancel out and they have x minus 1 is equal to ln 2. So x is equal to ln 2 plus 1, which is, again, ready for the calculator. You can do that right there. Okay, you can get the ln of 2 and then add 1 to your answer, and you'll get this number right here, and this is your x-intercept. We can plug that in, 1.693, somewhere around right here. So your graph is going to look like this here. Okay, and that makes sense because if you look at the OG graph in the upper right corner, okay, you can see that there has been a reflection around the x-axis. So it's been flipped over, and then we can do our domains for this. Once again, all exponential functions, the domain is all real numbers, goes infinitely to the left and to the right. But the range here has been restricted, okay? It hits a minimum of negative infinity, goes all the way down, but doesn't go all the way up. It maxes out at 4 and doesn't actually touch 4, so we want to put a round bracket there instead. And there we go. We have just created an E-graph with all of the essential information. And there we go. Let's move on to some logs next.